Alright, so if you use your fingers, you were asked to do a problem like this before. Evaluate arc cosine 1/4. You would set it equal to a letter and then take the inverse, switch them, and then find them on your trig paper plate. And then look at your restricting domains, right? So essentially you're doing the same problem, but here you have sine. So the first thing I'm going to do is I'm going to box the problem that we were doing before. And we're going to do a substitution. Everyone say substitution. And here you get to pick your favorite Greek letter again. Sine of beta. What does that mean? Beta equals the blue box. Beta equals the blue box. Beta equals arc cosine of 1/4. We're going to solve this problem, but we're not going to forget that our real answer, or the real question they want us to figure out, is sine of beta. So really way at the bottom, I'm going to write in what is sine of beta. So that's what we're going to do, right? So we're going to do this problem, and we're going to get all the clues that we can get from there, and then we're going to figure out where is sine of beta, okay? All right, this is a type of problem we did yesterday, right? Class, what's another way of saying arc cosine? Inverse of cosine, right? Arc cosine and inverse of cosine are the same. Okay, from here, what do we do next? We switch them. We're switching the x value with the y value. And remember, you're removing the inverse symbol because you're switching them. What do I write? 1/4 equals cosine of beta. Okay. Now, previously, we would now figure out, okay, where's cosine in our trig paper plate, right? We would figure out the two quadrants. Figure out the two quadrants. Which two quadrants, class? 1 and 4. Now we need to look for 1/4. Question. Is 1/4 on our trig paper plate? Okay, this is what it means. This is 1/2, and 1/4, so I think 1/2 of $1 is 50 cents. 1/4 of $1 is like 25 cents. So it's somewhere in here, which means it's not on your trig paper plate. Really, the trig paper plate, or the unit circle, is a summary of drawing triangles. So now we get to go back to drawing triangles. I know, you're so excited. Okay, so from this point, cosine is positive. We said quadrants 1 and 4, and I'm just going to pick the easiest quadrant. What was the easiest quadrant? So let's draw a triangle in quadrant 1. Let's do that together. Here is beta. That's our angle, our starting point. I'm going to draw some random triangle. You have graph paper, kind of hurts us because we're not really drawing to scale. Class, what letter is cosine? In terms of x, y, and r? Huh? X over r. So that means x is 1. R value is 4. And class, what letter are we missing? The y value. So we're going to have to use Pythagorean theorem. Partner A, tell partner B, Pythagorean theorem. Brian, what is the Pythagorean theorem? Jade, what's the Pythagorean theorem? Ryan, what is the Pythagorean theorem?
Y squared equals x squared plus y squared.
Okay, let's go very slow, because you thought this was easy and a lot of you guys missed some simple things on your last quiz or test. You remember that part? You don't remember? Look at your quiz or test. I remember. So your R value is what?
4.
So 4 squared. Your X value? Y value? It's unknown, right? So we keep it y squared. No shame. Use your calculator. 4 squared is?
16.
1 squared?
1.
To solve for y, you're going to have to?
Subtract the 1.
What am I left with?
15 equals y squared.
Take the radical. Pay attention. Y is equal to
Radical 15. Oh,
plus or minus radical 15. But we're in quadrant 1, so y has to be positive. Okay. We have this triangle now. I have all the sides of the right triangle, and we're supposed to find sine. Sine is which 2 letters? Y over y over r. So y is what? Look here, a triangle.
Y is
Radical 15, and your r value is 4. So our answer is radical 15 over 4. So in this problem, look at the inside, set it equal to a variable. Remember, this one in orange is your end goal. Here in blue, beta is equal to your arc cosine 1/4. Trade them. Put it onto your triangle. Use Pythagorean theorem, and then find your trig function. Question? Yes, you're not going to use the new range on this problem. You don't need to.